Hello, welcome to the SAS and Teradata Technology Showcase. Today I'm joined by Lisa Dotson from SAS.
Hello.
And pwsegal from Teradata.
Hello.
In the first session, we had shown you how to load the data, and now we're going to show you how to cleanse that data in database. Lisa, would you mind telling us a little bit about in-database data quality and what SAS and Teradata have to offer?
Absolutely. What Paul's going to show us or walk us through today is a demonstration of the in-database data quality technology for your Teradata environments. Being able to cleanse data is important. We're going to see with some demographic data, which is more like contact type information, how we can do that. One thing to point out here is that part of the product that you get, there's a component that gets installed inside of your Teradata environment that's called a quality knowledge base. We refer to it sometimes as a QKB. It's the information contained within that quality knowledge base that helps us to better understand contact information.
And SAS and Teradata were the first to deliver in-database data quality functionality. So I'm going to turn it over to Paul to demonstrate the power of in-database data quality and what you can do to cleanse the data at the source. Paul?
Thank you. So I'm going to connect to my Teradata system, a 6-node 2800 in San Diego. Going to turn on some tracing so we can see what gets sent through into the database. And I will run all that. And then we'll get down into the data quality stuff. But before we start looking at the data quality accelerator, I'll give you a quick peek at the data. So we have 1 million rows and a sample of the data so you can see exactly what we're looking at. Looks like this. So we have customer identifier, a title, full name, street address, city, state, zip code, country, email address, phone number, and a whole bunch of other stuff. A couple of things to point out here. Notice the dates are in SAS format, even though they came from Teradata. And straight off the bat, we can see that there's some problems with the state. A lot of them have the typical 2-letter abbreviation, but here we have California spelt out. Here we have Arizona spelt out. New Jersey and New York are spelt out. So we've got some quality issues. And if we look through the data here, we don't have any indication of gender. So what we're going to do is use the data quality accelerator to cleanse that state information and to have a go at identifying the gender of our customers. So we'll start off with doing the gender. So the way we do this is we call a stored procedure inside the database, which makes use of that quality knowledge base that Lisa talked about before and executes a bunch of DS2 code inside the database. So I'm calling this DQ gender, and if you're familiar with the other data quality pieces within SAS, this should look rather familiar. It's the same name across all the products. So I'm telling it to do the name, passing in the data in this particular database object. It's a view called customer in the name data database. I'm passing through the full name, so that's what it's going to use to identify the gender. I'm going to bring back the customer identifier so I can link it back in later on. It's going into a table called custgend, so that will contain my customer identifier and my gender. And to use the English USA quality knowledge base. The quality knowledge base, as Lisa mentioned before, contains all the regional information. So this is going to do it typically for North American Anglo-style names.
And it's good to point out that the QKB is a locale base, right? So just as we talked about the Anglo names in the US, we have things like French for France because it is different than French in Canada. So it's both geographic and language specific.
Which makes it really handy. So I'm running it now. Remember, it's going against 1 million. And it took just under 9.5 seconds to estimate the gender for 1 million customers, which isn't too bad. So let's actually have a look at the frequency. So I'll run a proc freq. And there's a couple of things I want to point out here besides the results. The first one is actually the results itself. So we have females 44.04%. Males, 46.34%. And we have this U for unknowns. The reason we have some unknowns is we could just have a first initial. We could have a non-Anglo name like tar. We could have one of those gender-neutral names like Lindsay or Kim. That can be very difficult. So if we were really interested in that, we could actually extract all these U's, send them off to somebody to manually inspect and make a determination. The other thing I just want to point out here is we ran this proc freak. It's the proc freak that you've always seen. There's no difference in here other than we're pointing to a Teradata library. But if we look at the log here, you will notice that it actually sent the SQL off into the database. So the database did the aggregations, did the summarizations, and just returned the results back to SAS. So instead of bringing back a full million rows and then getting SAS to do the aggregations, it brought back the 3 rows we see here, and then SAS formatted it. You notice it ran really quickly as well. So it actually ran in half a second. And you'll notice the magic words in blue here. SQL generation will be used to construct the frequency and crosstab tables. So that has automatically pushed some work down into the database via that magical access engine that we mentioned in the other videos. So now let's just have a look at the state codes. So let's just see how big a problem we have. So again, I'll do a proc freak, and this time I'll just look at states. And we can see we've got Arizona, California, New Jersey, New Mexico, New York, and the rest are reasonably okay. So we need to do a bit of cleansing. So once again, we call this stored procedure, and it's the DQ standardize, which again, if you're familiar with the SAS data quality procedures, it's basically the same name as regardless of platform. We're telling it we want the state province abbreviation, where the data is coming from, what the column we are interested in standardizing is, again the customer identifier, the unique identifier, and it's going into a table called cust state standard, STD.
I think it's good to point out here where you show the state province abbreviation, we call that a definition, a standardization definition. And with that QKB, you get many out of the box already done for you definitions on how things need to be standardized. This one in particular, for example, corresponds to the United States Postal Service standards for abbreviation. But there is a plethora of definitions that come out of the box.
And again, using the English USA quality knowledge base. So I'll run this. And again, it's going through those million records, standardizing, writing it out to another table, and it's done. 5.5 seconds exactly to standardize 1 million records. So let's go and have a look at the results. And everything's looking the way we expect it to look. It's all 2-character abbreviations. Again, we look at the log, we get the magic words, SQL generation will be used. Took half a second to do that frequency analysis. And if you're interested, there's the SQL that was passed through.
Paul, thank you. That was fantastic to show how we can actually address data quality issues using SAS technologies inside Teradata environment. Keep in mind, data quality is one of a big issue if you don't address it at the source. And if you don't do the data quality from the beginning, you're going to get very dirty data. And Paul, Lisa, thank you. And thank you for your attention. In the next session, we're going to show you Code Accelerator, or DS2, to help you manipulate the data so that you can process the data faster inside database. Thank you.